The reheat can happen most effectively in a direct digital control or DDC system by looking at all those zones and actually resetting that temperature to make sure they're all happy, but just happy, so that one of those zones has its damper fully open and it's receiving maximum airflow. Another way to adjust it is with an outside air temperature reset, and both of these methods meet the code requirements. One new requirement in the code is that an interior zone box shall be designed for that reset temperature. So in other words, if the reset temperature is 62 degrees, that means that an interior zone, which has a fairly consistent load, shall be designed to meet its load requirement with that 62 degree Fahrenheit temperature. That means a higher airflow for this zone, but it also means that we can meet the requirements of that zone and other zones with that reset temperature, and the reset will be able to function. Another change in the VAV portion of the code relates to the zone box minimum airflow. So the old code required a 30% zone box airflow maximum during a deadband, or it could be the minimum required to meet ventilation in that space, although that rarely applies. That limit of 30% is dropped to 20%. What that means is that when a zone is between heating and cooling, when it's in that deadband or neutral temperature zone, the airflow needs to throttle back to 20%. There is an allowance for an increase of up to 50% at full heating to avoid stratification, and we'll look at why that makes sense. Also, the language now clarifies that a 5-degree deadband is required in VAV boxes. This actually has been a requirement for more than a decade in the code, but it was a general requirement and sometimes it got forgotten when it came to a VAV system. So that 5-degree deadband also applies to a VAV system, and the language has been revised so that we are clear that that is required, because it's important to have that deadband for a VAV box to operate properly. Now let's look at a quick example of the VAV box airflow turndown so we can understand why it's so important to get a lower airflow when we are in that neutral deadband space. So let's say a zone does need some heating. It might need 16,000 BTUs per hour of heat to heat above the room set point of 70 degrees. Well, because the air coming into that box is colder, it means that with a 30% minimum, I'm going to require 41,000 BTUs per hour to meet that 16,000 BTU hour heating load. When I reduce the airflow to 20%, or in this example 1,000 CFM, it turns out that I reduce that reheat requirement to 33%. So in this example, that 33% airflow reduction, I reduce it to 33,000 BTUs per hour. That airflow reduction results in a fan reduction of energy use of 55%, and in fact that reheat savings results in a 24% gas savings back at the boiler once you calculate in boiler efficiency. So let's look at how these controls work. Now, you might find diagrams like this in the sequence of operation, or you might find a sequence of operation that describes this turndown, or a commissioning report would tell you that this requirement had been met. So basically this is the old requirement of a single maximum. So we have a maximum airflow throttling down with cooling to this 30% minimum during deadband. We sit at deadband at 30%, and then we continue with that 30%, but open up the heating so that the heating increases as it's needed for reheat. Under the new requirement, we have what's called a dual maximum. So I have my 100% maximum for cooling just as before I throttle down, except now I throttle down to 20% That lower airflow saves me energy, both fan and reheat energy through the deadband range, or no reheat energy here, but it saves me fan energy, as well as I avoid overcooling the space during the deadband range. And then when heating is required, I begin to open my heating valve until I reach a maximum discharge air limit, or until the sequence calls for the airflow to increase, and then I increase my airflow until I hit 50%. So this is the new requirement. Again, it's not required to increase the airflow, it's allowed, but it is required to reduce the box minimum to 20% during this range. And again, this may be somewhat complicated. Your engineer who's designing the system will typically demonstrate that they've met this requirement, or you will find the answer in a commissioning report or in the sequence of operation.